All right, today we are going to talk about containers in MeghHA and specifically how we can use redundancy from inside the container. The container and contained components in AMF are defined in the 4.1 spec. Allows HA to be done by an application running inside the Docker container or the LXC container, whatever you're going to use. It's not mandated what you use. Just some little architecture talk here. A container is not a separate node in terms of the redundancy cluster, the OpenSAF cluster. That means that the container does not require separate networking to do the HA. It communicates directly with the host through some sockets, some file sockets that are passed into the container. So you can scale up high and it's not going to be networking issues going across. There are two parts to this. There's a container component which manages the life cycle of the contained component. The contained component is the actual container, like the Docker container. And then the container component is sort of the parent that controls the life cycle of the Docker container. It starts it, stops it, that kind of stuff through some callbacks that we'll see in a little bit. The contained component can be any redundancy group that you want. It can be active standby, 2N, it can be N plus M, it can be N-way, whichever one you need for your application, it can do that. The container is always N-way active, just because it needs to be active on every node where it's going to be controlling the life cycle of containers on that node. So here's just a basic site of how the registration and the instantiation process for a contained component takes place. First, the container component comes up. After it gets an active assignment, now it can control the contained components and instantiate them and give them assignments, active or standby assignments. So this just walks through a little bit about how that works. And this is fully defined in the spec as well. Pictorially, it looks like this in terms of the redundancy groups, right? The container component, which is, again, the one that controls the life cycle of the contained, always has to be N-way active. The contained components, which are the Docker containers here, can be any redundancy group that you want, that your application needs, and they can be mixed. You can have some that run in an N plus M, some that run in a 2N. So now let's get into looking at how this actually works. Okay, so let's look at here. We can see we have a container running on this node, and we're going to go back and we're going to see that it is running in standby mode. You can see this right here. This contained component is running in standby mode. And then we're going to go and look at this other side here. We're going to see that this guy is running in active mode. We have these containers are set up to run in just active standby mode. We can see here that we have one container running here. So now what we're going to do is we're going to simulate a fault. We're going to kill this container, and we're going to watch the other guy take over as active. So let's kill this. go back over to here, and we'll see that you see this guy just became active. And then let's go back and see what happened when we killed this container. Now you can see that this container, this is when we noticed right here that the component died. So we're performing a failover, terminating, letting the system know that container is gone now. Now we're reinstantiating it here. This is the container component, the parent that's reinstantiating the Docker container. And then you can see that this gets a standby assignment. And if we look here, we can see that this guy just came up about a minute ago.